So on December 9th, 2021, I published a sonic gravity episode called Quantum Gravity at the Speed of Thought. And in it I described the Rosetta Stone of the universe, the geometry of the universe, that once I understood, all of the mysteries in theoretical physics just fell into place, and that is a fact. Now I didn't make up the idea that our universe was inside a black hole, and the surface of that black hole is actually a two-dimensional hologram. That wasn't me, that was Gerard Hoof, probably based off Jacob Bekenstein's black hole entropy solution. Stephen Hawking was in on it, and especially Leonard Susskind. There's probably some other guys that I don't know, but you can thank them, because Leonard Susskind figured out that all the machinery and physics and matter and energy in a universe could be encoded on a 2D holographic surface, and that is a fact. And Stephen Hawking talked about Hawking radiation. There was black body radiation, heat, and it's the sonic gravity theory of everything, that our consciousness, vibes, soul, spirit, energy, running over the 2D holographic surface of a black hole, encoding a universe inside. And our consciousness receives information from the surface of the hologram the same way our brains receive information from our senses, because our brain doesn't actually experience the physical world around us. All our brain experiences are input signals, bioelectricity, input signals from our nerves and senses, because our brain is really sitting inside a sensory deprivation chamber inside our skulls. It's just interpreting energy that it receives. And the sonic gravity theory of everything is that our consciousness could actually be sitting on the surface of this hologram. And I don't want to blow your mind too bad, but we are the cosmic librarians, the observers in the universe, and we are the mechanism for the law of conservation of quantum information. And we're recording information in our memories and in our DNA. And that's as far as I'm going to go with that one for right now. I don't want to totally freak you out. But later on, we're going to pick up where we left off with that. And then I'm really going to bake your noodle. And that is a fact. Because right now you're orbiting in my sonic gravity and you are viewing the universe through the eyes of a madman. And this is a theory of everything, so we got to be careful not to totally zip off in random stream of consciousness directions. But the main takeaway for this observation that we're making today, right now, in your mind, is our consciousness can only receive information from the changing hologram. So if it's not in contact with the hologram, it's not observable, and it's nothing that we can interact with. It's nothing that our consciousness can interact with, and that is a fact. So if it's off the hologram, it's what we call weakly interacting. It's what we call weakly interacting particles, or WIMPs, or maybe weakly interacting energy is better. And we could just call it wee. Anyway, if it's off the hologram, it's wimpy, and that too is a fact. Because one of our limitations as observers is if it's not in contact with the hologram, we can't see it, and that too is fact. Except that we'll see that the Higgs string, the gravity, is still tugging on the hologram even when matter is orbiting off the hologram. It's still tugging on the hologram, so it's still deflecting space-time. It's still deflecting the two-dimensional holographic surface of the black hole, so it still bends light, and it still has gravity, even though it's off the hologram, and that too is a fact. So yeah, sorry Mond. You can just throw all those draft papers in the garbage, because that's pretty much it for Mond. And that too is a fact. And I didn't mean to slay Mond. It's just collateral damage. I didn't even intend to sort out the theory of everything. All I wanted to do was figure out how UFOs fly. It's just weird. It just happened. And when it did, I just figured everything else out too. And that is a fact. Probably. Maybe. I'm pretty sure. And so to all those Mond haters out there, you're welcome. And in the math, when it's off the hologram, it's what you call a complex number. It will show up as an imaginary number, which is identified as multiplied by the square root of -1. And that too is a fact. And we'll come back to this when we get into the quantum Lagrangian, but that's what it means in the math when you see a little italicized lowercase I in whatever equation you're looking at. It's off the hologram if it's multiplied by a I, by a little lowercase italicized I. And that is a fact. And we'll talk about it later when we cover the equation for quantum gravity and universal expansion. But space-time actually blows out of the black hole. Space-time blowing out of the black hole, which is the reason that the universe is expanding the farther you look out, because there's more black holes between you and wherever you're looking. Space-time blowing out of the black hole is changing the hologram, and that's what we notice as the passage of time. So I want you to think of the universe as a movie reel, one of those old school movie reels. And every frame in the reel is a picture of the exact energy state of the universe at that instant of Planck time. And if we chop all the frames out of the reel and stack them from the beginning of time, from the Big Bang to the end of time, the distance across the edges of those frames of Planck time becomes time-like, from the beginning of the movie to the end of the movie, across the stack, across the slices of cheese. And I made a misstatement during the last sonic gravity theory of everything sort of illustrated tutorial that I did about black hole genocide. premises, because I said that if you were to go, because I said that the spot, the hole in the quantum donut that was a black hole, that if you went through that, you'd go somewhere like to the next, you'd be able to enter that next universe. And I don't think that's right. I misspoke. I wasn't totally critically thinking, because the space inside the radius that we calculated, the luminal velocity radius, the Voorhees radius, wasn't moving faster than the speed of light. So it never left its instant of Planck time. It didn't go back in time. And so when the supernova happened, everything that was inside that little donut hole should have blown out as stardust in the supernova. The same way that the sort of outer layers of the plasma of the star, when it collapses, I think it provides some confining pressure that really holds the core in so that the core can actually spin at superluminal speed. But I think the outer layers of the plasma also form a big part of the stardust and material that blows out when the space-time rips and the quantum donut goes back in time. And it goes back in time just like Einstein said it would, and none of the slices of cheese in the past can accept it, because it would violate the law of conservation of mass energy, and it would be creating energy in that instant of Planck time. So every Planck time rejects it until it goes all the way back before the beginning of time, and then the space inside that quantum donut, that mass that went all the way into the past because it was spinning superluminally, I think the tension in the Higgs string rips open that core, and the weak nuclear force rends all the matter into pure energy, and the space that was inside the core of that star, still quantumly entangled to the edges of space in the parent universe, inflates, results in a big bang, and all the energy and space in that universe is sort of field tied, is quantumly entangled to the instant of Planck time way in the future where the black hole ripped out. And it's that tension, it's that gravity that is pulling the space and energy, expanding it in the baby universe, but blowing it, but pulling it back into the parent universe. And that's one of the big mysteries that theoretical physicists don't understand right now, and that's what they're calling dark energy. It's really just the space-time that's uncoiling out of the baby universe, out of black holes, into the parent universe. And that's why I think space-time is uncoiling into the parent universe out of the black hole. And I think the Higgs field is negative energy density. I think it's gravity. And it's that tension in the Higgs string between the baby universe and the parent universe. That quantum gravity, that tension in the Higgs string, is what creates black hole gravity. And the reason that black holes evaporate and slowly get smaller is because as the age of the baby universe approaches the age of the parent universe, where it ripped out of time, the tension in the Higgs string is relaxing. And when the baby universe, because everybody knows that time stops at the surface of a black hole, when the baby universe, the space in the baby universe, when the baby universe's age catches up to the age of the parent universe, I think the space-time is healed. And all the space in the baby universe is uncoiled into the parent universe. And that is probably a fact. Maybe. Probably. I'm pretty sure. But for dark matter, the takeaway is that every one of those slices of cheese, every one of those instants of Planck time is one Planck length thick. And you've probably realized that the sonic gravity theory of everything suggests the Higgs field is the gravity field, and the Higgs boson is the graviton. And that the job of the Higgs field, that the Higgs field exists inside the plane of that slice of cheese, of that instant of Planck time, in the frame of that movie. And the job of the Higgs field is to leash the matter and the energy in that slice of cheese, in the universe, to that instance of Planck time. And quantum gravity is the tension in the Higgs string, tension of the string getting dragged across time via time dilation. But now that we understand that each one of those instances of time, each one of those slices of cheese or frames in the movie, that all the matter and energy is leashed to that instance of time by the Higgs field. And you're going to see, and the geometry of that leash is what's going to give us dark matter. So the 2D holographic surface of the black hole is the state of energy across the entire universe at one instant of Planck time. And if we peel the surface of the black hole off and hang it like a sheet, and if we look at it sideways down the skinny 1 Planck length wide dimension of that sheet, the Higgs field, you can think of the Higgs field as embedded in that sheet. And you can think of the Higgs string as anchored inside that instance of time, inside that slice of cheese, and it's leashing all the matter and energy in the universe to that one instance of Planck time by the Higgs string. And so it's really like a tether. And you can think of all the matter and energy oscillating in a circle, leashed to that plane at one point by the Higgs string. And the smallest thing anything can be is 1 Planck length. So I think the Higgs Higgs string is 1 Planck length long. And so matter can stray 1 Planck length to the left or right, forward in time or backward in time, without engaging the Higgs string. But when it goes 2, that's when the Higgs string engages and whips it back to the other side. So the matter and energy is oscillating in a circle, in a 4 Planck length diameter circle, whipping around and around in a circle, putting tension on the Higgs string. And the tension on the Higgs string is yanking on the surface of the black hole, on the surface of space-time. And it's that tension that warps light and does all the things that gravity does, because it's quantum gravity. And as you can see, when that matter whips around in that 4 Planck length diameter circle, it only intersects the hologram at 2 places, like at the 12 o'clock position and the 6 o'clock position. It's going into our time from the future and coming out of our time from the past. It's only in 2 different spots, and that's really important, and it will reveal a lot of mysteries in theoretical physics that you will see in just a second, and that is a fact. And so you can see in that little picture, I drew it in and I colored in the circles where the matter is all oscillating off of the hologram, and in the empty circles, like the white circles, they're in contact with the hologram, and that's only the observable part of the matter in the universe. So really only seeing like the tip of the iceberg of the matter in the universe. We can only see it interact with it when it's intersecting the hologram, because that's where our consciousness gets its information from. But you can see how even though like when the matter's all oscillating around, it's still tugging on the Higgs field. It's still tugging on the Higgs string. All that matter oscillating around is still tugging on the Higgs string. It's pulling on the Higgs field on the surface of the black hole. Now it's still there, but we can't interact with it. It's identified in the math as imaginary. And yeah, that is dark matter. That is exactly what dark matter is. That is all dark matter is. It's our matter. We just can't interact with it because it's off of the hologram. And that is a fact. So yeah, if you're working on papers about dark matter and you're trying to say it's like some kind of exotic particle or whatever, you can just throw them in the garbage, because guess what? Our matter is dark matter, or dark matter is our matter, or part of our matter. You know what I mean. So all you Mond people who are dark matter haters, who are still mad about having to throw your papers in the garbage, well, guess what? Everybody else who's looking for dark matter has to throw their papers in the garbage too, and that is a fact. So you're welcome. Now it's even. Everybody has to throw their shit in the trash, and that too is a fact. But now that we know what dark matter is, it's time for the main event. Here's the derivation of the God equation. So we look at all the matter in that diagram. It's all oscillating around a 4 Planck length diameter circle. And what that means is that the circumference of the orbit comes from regular geometry. It's pi times the diameter is the circumference of a circle. And so pi times 4 Planck lengths tells us that the orbit is 12.55 Planck lengths long. But because the hologram is 1 Planck length thick, and the orbit intersects the Planck length thickness of the hologram twice in its orbit, for only 2 Planck lengths of that orbit is the matter in the universe observable. And that leaves 10.55 or 10.6, just rounding up, Planck lengths of unobservable matter. And during that 10.6 Planck lengths per cycle, that matter is dark matter, and that is a fact. It's still got gravity. It's still there tugging on the Higgs field, which is bending space-time, because the Higgs field is inside our slice of cheese. It's inside our 2D holographic surface of our black hole, and it's bending it as it tugs, as that matter swings around and tugs on it. So it's still gravity, just like general relativity says, bending space-time the same way general relativity says that mass bends space-time, because mass is energy, and so is this. But 10.3 Planck lengths of that orbit is dark matter. And so when you put the ratio of 2 Planck lengths to 10.3 Planck lengths, and you reduce it down, you get the measured ratio of matter to dark matter in the universe, which is 1 to 5.3 or 5.25, 1 to 5, and that is a fact. And that's actually measured by physicists, so you know it's right. That too is a fact. And so the God equation for the energy of mass, which is just E equals mc squared, only except for it includes all of the dark matter that Einstein didn't know was there. So the God equation for the energy of mass, the Einstein-Voorhees energy of mass, the God equation is 4 pi divided by the G factor for the electron times the observable mass times the speed of light squared. And that's just E equals mc squared, except for you're labeling m as only the observable mass, and then you're factoring it, essentially 4 pi divided by 2, so that it catches all the mass in the orbit. And that is a fact. That is the God equation. And that too is a fact. And so this G factor that I just threw into the God equation, I haven't really talked about it, but I want to explain it, because if somebody doesn't know about it, I don't want them to think that it's just word salad and I'm making it up. But the G factor is also a mystery in theoretical physics that we're going to cover, and that's like a completely different mystery that this Rosetta Stone Stone of the universe totally resolves. The God equation in dark matter totally resolves the G-factor problem. It also reveals why the Fermilab discovered that the muon G-factor is bigger than the electron G-factor. And they were talking about, oh, it's new physics. It's not new physics. It's really easy. But the thing is I'm about ready to talk about it. And that's like a whole separate, different mystery of physics. And I just want to know if they're going to bundle it all, like if it was my birthday on Christmas and they're just going to give me one Nobel Prize for it. Because I told everybody why the muon G-factor Fermilab experiment was what it was, why the G-factor was what it was, and what the God equation for the energy of mass is, and what dark matter is, and I already gave away dark energy. And so even though I'm throwing all this in one little tutorial, I really hope that the Nobel Prize Committee kind of looks at it with an open mind and says, you know what, we're not going to give you your Christmas present and your birthday present rolled together, Brad, because you deserve a Christmas present and a birthday present. So I hope they view these as separate Nobel Prizes. Oh, and don't forget Black Hole Genesis, where we all found out that black holes are donuts. Oh yeah, and I think I already gave away dark energy too, which also totally explains universal expansion and the cosmological constant. So, well, you're welcome. Tell on that. Anyway, sorry about that. Let's get back to the G-factor. So the G-factor is essentially 2. And a G-factor was the cheat that arose from the Einstein-de Haas effect, which is from a pretty brilliant experiment where Einstein and de Haas hung a big block of iron and put it in a magnetic field. And when the iron was not in the magnetic field, you know, all the electrons were all just kind of jumbled up and rotating around in random directions and everything was still. But then when you apply the magnetic field, it kind of straightens out all the electron orbiting and essentially sort of pushes off. You know, the inertia is conserved. The angular momentum of those electrons is conserved, and when they all flip over, the thing starts rotating. And that's because of conservation of angular momentum. But the funny thing was that when they calculated the electromagnetic dipole moment, which is essentially the spinning energy of all them electrons zipping around, they did their theoretical calculation, and the measured value was always twice what the theoretical calculation was. And so they just did like they do for the free energy of the electron in Feynman path integrals and all that kind of stuff, is they just cheat. And they say, well, we're going to multiply it by 2 and then we know we're good. And they call that the G-factor. But the thing is, the reason that the G-factor is the G-factor and the G-factor is 2 is because Einstein and de Haas didn't realize that all the matter in the universe was orbiting, tethered by the Higgs string, anchored in the two-dimensional holographic surface of the black hole of our universe, into the space-time of the universe. And when it swings around, like the picture we just described, the Rosetta Stone of the universe, all that matter is orbiting in a 4 Planck length diameter circle. And it's intersecting the hologram at 2 spots, the 12 o'clock and the 6 o'clock, or the pi over 2 and the minus pi over 2 position, however you want to call it. And what that means is that there's 2 impulses along the swing, not just one. And that's why the Einstein-de Haas effect and the G-factor had to be 2, because they thought it was just swinging around with one impulse. But no, it's swinging around, hits the hologram twice, and so there's actually 2 impulses per cycle. And that's why the measured electromagnetic dipole moment is twice what the theoretical calculation is. But if you have the Rosetta Stone of the universe and you base it on that, then the theoretical calculation matches the measured electromagnetic dipole moment, and that's a fact. But there's also an anomalous electromagnetic dipole moment, and that's also explained by the Rosetta Stone of the universe, because the sheet of Planck time actually isn't straight up and down, right? It's part of a donut. And so that means no matter where you slice it, it's curved. And so the anomalous electromagnetic dipole moment is actually the extra fractional contact with the hologram because it's bent down a little bit, because it's curved. And so it also explains the anomalous electromagnetic dipole moment, which is the electromagnetic dipole moment for the electron is like 2.00016 or something like that. So it's a teeny little fractional extra amount of moment that arises from the extra contact from the curvature of the black hole, or the donut, so to speak. And that is probably a fact. Probably. I'm pretty sure. And then if you remember the muon G2 experiment, everybody thought it was such a big deal. And I'm actually going to kind of rain on that parade a little bit too, because there's actually no difference between the muon and the electron. It's just velocity, because things change mass depending on the velocity. But that is the quantum Lagrangian. And I'm keeping that in a separate one because I don't want that to be the same Nobel Prize as this one. And actually, really, I got to break it down and put it in a different one because, you know, these get kind of dense and everybody kind of gets tired of thinking about it. So anyway, it's coming. In the Sonic Gravity podcast, I am talking about the quantum Lagrangian, and that's going to be probably one of the next tutorial videos I do. But you could probably figure out everything about the Lagrangian from the 2 tutorial videos that I've got now, this one plus the black hole genesis video. Anyway, bottom line is that the reason that the Fermilab discovered that the muon, which is just incorrectly thought of as a higher energy sort of electron particle, it's just a slower electron, just saying. And they think it decays, but it doesn't really decay, it just accelerates as some positive ion picks it up and it starts to orbit at the speed of light almost. Anyway, bottom line is that when the muon, or the electron, is released when the atom that it's orbiting explodes, they calculated, or they measured the electromagnetic dipole moment of the muon, and they found that it was a little bit bigger. The G factor for the muon was a little bit bigger than the G factor of the electron. And that makes perfect sense when you look at the Rosetta Stone of the universe, when you take a look and you see that the electron is orbiting around a 4 pi diameter circle, intersecting the hologram at 2 places. Well, imagine if that electron is 200 times as massive, right? If the electron has 200 times more observable matter, right, then it's going to swing out a little bit further, right? We're going to be able to observe it, we're going to be able to measure it, and it's going to stretch out and rotate out a little bit further than the electron. And so that's going to give it a bigger moment arm, so it's going to give it a little bit bigger torque. It's going to give it a little bit bigger moment. And it's obvious, right? Yeah, it's not new physics. It's not a new particle. It's actually just totally obvious, right? I mean, if it's heavier, it's going to swing out further. It's going to cause a bigger dimple in the surface of the hologram where the tether is anchored, where the Higgs string is anchoring it to our instance of Planck time. And so that's why the muon G factor is a little bit larger than the electron G factor. That's all it is. It's really nothing, right? So, I mean, it's obvious once you have the Rosetta Stone of the universe to look at. And that is a fact. So there you go. That's the sonic gravity Rosetta Stone of the universe. Quantum gravity is tension in the Higgs string. Dark matter is matter and energy off the hologram, but still tethered to the surface of our 2D holographic black hole. Dark matter is still the same matter and energy that comprises the universe. It's just off of the 2D holographic surface of the black hole. It's identified in our calculations as imaginary until it intersects the black hole and we can interact with it and it becomes observable. The God equation, the Einstein-Voorhees energy of mass equation, is 4 pi divided by the G factor for the electron times the observable mass times the speed of light squared. And that explains the Einstein-de Haas effect. It reconciles the Fermilab's muon G2 factor experiment results and explains the anomalous electromagnetic dipole moment. And just as collateral damage, we also covered universal expansion. We already covered dark energy. We got all the people who are working on Mond papers to throw them in the garbage, and then we made them feel better because we made everybody who's also working on dark matter throw theirs in the garbage too, and that is a fact. So thanks for listening. Stay tuned for the quantum Lagrangian and the solutions to all the rest of the mysteries in theoretical physics. We're not just going to talk about all the boring mysteries in theoretical physics that people have thought of that can't figure out. I'm going to give you the solution to the Yang-Mills mass gap. I'll tell you how UFOs fly, anti-gravity, time travel, zero-point energy propulsion. But the cool stuff is stuff you've never thought of. Why we get tired. Why can the bumblebee beat its wings at 600 times a second? Why is the hummingbird so fast? I'll give you a clue. It's not because it has fast muscles. It's because its consciousness slows the flow of its time, and that is a fact. Why your soul is immortal. What happens when you die. It's coming. It's coming as you orbit in sonic gravity and see the universe through the eyes of a madman.